In this lesson, you will learn how to find areas of quadrilaterals. The first type of quadrilateral that we will look at is a parallelogram. And the formula is area equals base times height. So the base can be the segment along the top part of the parallelogram or this bottom part here, but the height has to be the perpendicular distance between the base. So it can be this length inside or this length outside. The next type of quadrilateral is a rhombus, and the formula for area is the same. Area equals base times height. Since in a rhombus you have all four sides that are equal, it doesn't matter which four of these lengths are your base, but your height has to be the perpendicular distance between two opposite sides. The next quadrilateral is a rectangle, and area is base times height, so we just want the top or the bottom, or one of the two sides. And then in a square, because you have four equal sides, the area is just side squared. So just take one of the sides and square it. And the last quadrilateral is a trapezoid. And the formula for the area of a trapezoid is 1/2 times the height times base 1 plus base 2. So your base 1 and your base 2 are the two sides that are parallel to each other. The height is the perpendicular distance between them. So the directions are to find the area of each quadrilateral. And in this first shape, we have a parallelogram. The formula for the area of a parallelogram is base times height. The base is equal to 7.2, and the height is equal to 6. So when I find the area, we want to take 7.2 and multiply it times 6. And when I multiply them together, I get an area of 43.2, and area is always measured in square units, so it's centimeters squared. For number 2, we have another parallelogram, so I start by writing the formula base times height, and the base is equal to 5, and this time the height is given as the outside length of the parallelogram. As long as it's the perpendicular distance, or the side that forms the right angle, your height is equal to 3.1. So my area is 5 times 3.1. So if I multiply that out on the side, I get an area of 15.5. The units are in inches, and area is always squared. So 15.5 inches squared, or square inches. For number 3, another parallelogram, so area is base times height, and we have a base equal to 8. Now the problem is that we're not given the height. This 6 out here is just one of the sides of the parallelogram, but it is not the height. The height is the perpendicular distance. So this length right here is our height. So the way we're going to find our height is by using this 30-degree angle that's given in one of the angles of the triangle that I just formed. So since we have a 30-degree angle, and a 90-degree angle, that means the missing angle of this triangle is 60. We know that this side is equal to 6. So the only way we could find this height is by using the special 30, 60, 90 right triangle. So in the 30, 60, 90 triangle, the side across from 30 is equal to x, the side across from the 90 is equal to 2x, and the side across from the 60 is equal to x root 3. So in the 30, 60, 90 triangle, the side across from the 30 is equal to x, the side across from the 60 is equal to x root 3, and the hypotenuse, or the side across from the 90, is equal to 2x. So the only value that I am given in the triangle is the 6, and the 6 corresponds to the 2x. So if I write an equation, 2x is equal to 6, I can solve for x by dividing 2 by both sides of the equation to get x equals 3. So knowing that x equals 3 makes this side 3 and this side 3 root 3, but the side that I am really interested in is the height, which is 3. So this length here is equal to 3. So now that we know that the height is 3, we can finish the area by finding base times height, 8 times 3, and we get an answer of 24 square inches. For number 4, we have a rectangle, and the formula for the area of a rectangle is base times height. Now in this problem, the height is given, the height is equal to 5, but our base is not given. This side here is our base. And this diagonal that's drawn through a right triangle For number 4, we have a rectangle, and the formula for the area of a rectangle is base times height. So in this example, the height is given. Our height is equal to 5, but our base is not given. Our base is this length here at the bottom. And since the diagonal forms a right triangle in a rectangle, we can use the Pythagorean theorem to find the missing length. So if I take a squared plus b squared and set it equal to c squared, I would have 5 squared plus b squared. 13 is the hypotenuse because it's across from the right angle, so it's equal to 13 squared. And I solve for b. 5 squared is 25 plus b squared. 13 squared is 169. So when I subtract 25 from both sides, I'll finish up right over here, I get b squared is equal to 144. So take the square root of both sides to solve for b, and I get b is equal to 12. So the base of my rectangle is equal to 12, and that's the value that I need to find the area. So the area, base times height, is 5 times 12, and 5 times 12 is 60. Our units are meters squared. So the area of this rectangle is 60 meters squared. For number 5, we have a trapezoid, and the formula for the area of a trapezoid is 1/2 times the height times base 1 plus base 2. And the height is 4. The bases are the two sides that are parallel to each other. So it doesn't matter which one you make base 1 and which one you make base 2. I'm just going to make this top one base 1 and this bottom base 2. So we have a height of 4. We have base 1 equal to 3.1. And we have base 2 equal to 5.6. So once I have all of my values, I just substitute them into the area formula and calculate the area. So I have 1/2 times 4 times base 1 is 3.1 plus base 2 is 5.6. So starting with 1/2 times 4, 1/2 times 4 is just equal to 2 because this 2 So starting with 1/2 times 4, this 2 reduces to 1 and the 4 reduces to a 2. And if I take 3.1 plus 5.6, I get 8.7. So if I take 2 times 8.7, I get 17.4, and the units are in feet squared or square feet. So the area of this trapezoid is 17.4 square feet. For number 6, we have another trapezoid, and if I start by writing the formula, I have 1/2 times the height times base 1 plus base 2. So in this example, we definitely have our two bases as the 12 and the 18. So I'm going to label the 12 as base 1 and the 18 as base 2. The problem is that we don't have the height. So the height of a trapezoid is the perpendicular distance between the bases. So this length here is our height. So let's label what we have so far. We have base 1 is 12, base 2 is 18, and the height is what we need to find so that we could find the area. So this 18 refers to this entire base right here. If I were to draw two lines straight down, this 12 that's on top, that's our top base, is the length between our two heights that I just drew. So if this whole length is 18, that would make this length 3 and this length 3. So 3 plus 12 plus 3 is equal to 18. So now that I've found the 3, I can use this right triangle of 5, 3, and h, just the Pythagorean theorem, to find the height so that I could put it in the area formula. So a squared plus b squared equals c squared. I'll make the 3a and the h b, but the 5, because it's across from the right angle, has to be c. And we have 9 plus h squared is equal to 25. So to solve for h, I subtract 9 from both sides, and finishing up here, I have h squared is equal to 16. Take the square root of both sides, and we get h is equal to 4. So the height of our triangle is equal to 4, and that's the same as the height of the trapezoid. So now we have all of the parts of the formula, and now we can just substitute it into the area formula. So 1/2 times 12 times base 1 times the height of 4 times base 1 plus base 2 is equal to half of 4 is equal to 2. 12 plus 18 is equal to 30. 2 times 30 is 60, and our units are in meters squared. In number 7, it looks as though we have a square, and the reason why I know it's a square is because the diagonal of a square divides the right angle into two 45-degree angles. So we have a 45-degree angle here, and here, and here. And the formula for the area of a square is equal to side squared. So we are not given any of the sides of this square. But what we do have is a triangle where the hypotenuse is equal to 6 root 2, and the two angles are 45 degrees. So whenever you see a 45-degree angle, you want to think of the 45-45-90 reference triangle that can be used to help you find the missing sides of a right triangle. And the two legs of the 45-45-90 triangle are both equal to x, and the hypotenuse is equal to x root 2. So the side that's given is the 6 root 2, which corresponds with the x root 2. So to solve for x, if I take x root 2 and set it equal to 6 root 2, dividing both sides by root 2 will help me solve for x, so that I get x equals 6 because both of these root 2's cancel. So knowing that both of these sides are equal to 6, then both of these sides are equal to 6, and the side of my square is equal to 6. So with each side equal to 6, the area is equal to 6 squared, which is equal to 36. So the units were not given on this one, so we will say that the area is 36 square units. For number 8, we're asked to find the area of the figure, and what we have in this figure is a square here, and then a triangle here. So if we want to find the area of the figure, we want to find the area of a square and add it to the area of a triangle. The formula for the area of a square is s squared, and the formula for the area of a triangle is 1/2 base times height. So looking at the square, I don't have any of the sides of a square. So that means I can't start with the square. I have to start with the triangle. And this length of the triangle is the base, and this length of the triangle is the height. So we know in the triangle that the height is equal to 4. to find the base, I'm going to use the Pythagorean theorem to find half of the base and then double it to find the full base. So if I take this triangle and just draw it out on the side, I have a 4 and a 5, and I'm just going to place an x here, and using the Pythagorean theorem, a squared plus b squared equals c squared, I'll let the x equal a, the 4 equal b, and the hypotenuse has to be 5 because it's across from the right angle. I have x squared plus 16 equals 25. So x squared is equal to 9, and when I take the square root of both sides, I get x is equal to 3. So with this length equal to 3, we have a 3 here and a 3 here, which means that the entire base is equal to 6. So to finish the area of the triangle, I have 1/2 times 6 times 4, which is half of 24, and half of 24 is equal to 12. So now that we know that each side of the square is equal to 6. So to find the area of the square, this one is much simpler. Each side is equal to 6, so the area is 6 squared, which is equal to 36. So therefore, the total area of the figure is 36 plus 12, which is 48, and our units are square inches. So number 9 is our first problem where we don't have a picture. So anytime you don't have a picture, you should always draw one. So we have a parallelogram, and it says that the area is equal to 126 square feet, and we have a height of 14. The height is this length right here. So let's just draw that outside and say that the height is equal to 14, and we're asked to find the base. So the base is either the top part or the bottom. So in this time, we're not finding the area, we're given an area, we're finding the missing side. So area is base times height, and we know that the area is 126, so I substitute 126 in for A. We don't know the base, but we know that the height is 14. So to solve for B, I will divide both sides by 14, and if I take 126 divided by 14, I'll get a base equal to 9. So just make sure that you write the units. You have the area in square feet, the height in feet, so the base has to be in feet as well. So you have a base of 9 feet. For number 10, we want to find the height of the trapezoid if the area is equal to 168 square meters. So if I write the area formula for a trapezoid, it's 1/2 times the height times base 1 plus base 2. The height is this length right here. And we know that the area is 168. This 3.2 is our base 1, and 3.8 is our base 2. So if I take all of the values and substitute them into the proper letter, I have 168 equals 1/2 times the height is what we're looking for. Base 1 is 3.2, base 2 is 3.8, and we have 168 is equal to 1/2 times the height, and 3.2 plus 3.8 is equal to 7. So to solve for h, you have this 1/2 and this 7. So if we take 1/2 times 7, because they're being multiplied, we get 7/2. Just multiply straight across. So just to rewrite this as 168 equals 7/2 times h, we can solve for h by multiplying both sides by 2/7, so that these 2's cancel and these 7's cancel. So 2/7 times 168/1. 7 divides into 168. (24 times), and 2 times 24 is equal to 48. So therefore we have a height equal to 48 meters. So when you're finding missing parts, you don't have to put square units, you just put the units. So number 11 is another trapezoid problem. So I start by writing the area of a trapezoid formula: 1/2 times the height times base 1 plus base 2. So find the base of the trapezoid if the area is equal to 72 square feet. So this x is our base 1, 12 is our base 2, 8 is the height, and we have an area of 72. So I take 72, substitute it in for a. My height is equal to 8. Base 1 is what we're finding, and base 2 is equal to 12. So I'm going to start by reducing this 2 and 8 and just make it a 4, so that I have 72 is equal to 4 times x plus 12. And to solve for x, I will start by distributing the 4, and I get 72 is equal to 4x plus 48. I subtract 48 from both sides so that the 48's cancel. And 72 minus 48 is 24. So as my last step, I divide both sides by 4 and get x is equal to 6. So this x represents base 1, so base 1 is equal to 6 feet. For number 12, we're asked to find the area of the shaded region. And when you're finding the area of the shaded region, you want to look at the large shape and subtract out all of the smaller shapes inside. So the large shape is a rectangle. So first we'll be finding the area of a rectangle, and then we'll be subtracting the area of 2 squares. So let's start with the rectangle. The area of a rectangle is equal to base times height. And in this rectangle, 8 is our base and 4 is our height. So we have an area equal to 8 times 4, which is equal to 32. Next, we want to subtract the area of two squares. So let's find the area of one of those squares, since both of the squares have a side of 2, and then just multiply it by 2. So each side of the white squares in the middle are equal to 2. So area is equal to 2 squared, which is equal to 4. So one of these squares, if I come back to the picture, has an area of 4. So we have two squares, both with an area of 4. So we want to take 32 minus 2 times 4, which is 32 minus 8, and that gives us 24, and we want the units as inches squared. So the shaded region has an area of 24 square inches. For number 13, we'll do this the same way as number 12. We want to look at the large shape, which is the rectangle. So we're going to start by finding the area of a rectangle and then subtracting two triangles. On this example, however, the triangles are different. So let's call this triangle here triangle 1, and this triangle here as triangle 2. So starting with the rectangle, the formula for area of a rectangle is base times height. And the base is the length from here to here. So if I add that 3 and 4, I get a length of 7. The height is the length from here to here. So if I add the 1 and 5, I get a height of 6. So the area of the rectangle is 7 times 6, which is 42. So the area of the rectangle is 7 times 6, which is 42. So from this 42, we have to subtract the area of two triangles. So let's start down here with triangle 1. The formula for the area of a triangle is 1/2 base times height. The base of triangle 1 is equal to 1, and the height of triangle 1 is equal to 3. I'm just using this one here as my base and this 3 here as my height. So if I take 1/2 times 1 times 3, I get an area equal to half of 3, and half of 3 is equal to 1.5. Now for triangle 2, same area formula, area equals 1/2 base times height. The base of triangle 2 is equal to 4, that's this length right here, and the height is equal to 6 because in the rectangle opposite sides are equal. So the height is equal to 6, and if we calculate the area, we have 1/2 times 4 times 6, which is half of 24, and half of 24 is equal to 12. So the shaded area is equal to the rectangle, which had an area of 42, minus the two triangles. And the two triangles had a total area of 1.5 plus 12. So if I take 1.5 plus 12, that's equal to 13.5. So if I take 1.5 plus 12, that's equal to 13.5. And 42 minus 13.5 is equal to 28.5. Our units were in meters, so it's 28.5 square meters.